Example number 3. State the vertex of each of the following parabolas. Again, remember parabola is also a quadratic. And then list the transformations, don't abbreviate, that have occurred to each of the following quadratic expressions. And then sketch a graph of the transformed function. So first of all, let's start with the turning point, also known as the vertex, because we've been doing that throughout, so that should be very second nature to us. Change the sign, keep the sign. -3, -1. In terms of transformations, I'm going to start and read the graph left to right. Out in front of the graph, also known as outside of the function, is a negative. And when we have a negative outside of the function, that means that we are going to reflect over the x-axis. The vertex, the turning point, -3, -1, tells us which direction to go. Because when we graph -3, we go left on the graph. And when we graph -1, we go down on the graph. And let's start by graphing our vertex, -3, -1. Now you can't see it on the video, but I take my hand and I flip it upside down. Because this is the x-axis, so we're flipping over. So we're turning our graph upside down to graph. We've got the vertex, so we have a good starting point. The pattern is still the same. One space to the right, one up, but then we're going to flip over. We're going to turn it upside down. 2 spaces to the right and 4 up, except the 4 up now is going to be 4 down. 1, 2, 1, 2, 3, 4. And once we get the pattern on the right, the pattern on the left is the same. And when I say on the left, we're counting from the vertex. So from this point right here, so what we get 1 space to the left and 1 down, 2 spaces from that blue dot and 4 down, and here is our quadratic. If we look at problem B, this was on our practice, or at least a very similar problem on our practice for our shifting, and it gave some people some trouble. Here's the thing. Inside the parentheses, we have nothing added or subtracted to it. So as we look to define what the vertex is, there's nothing added or subtracted to the x. In the parentheses, nothing is represented by 0. And then our other part here is that we've got 4. So change the sign, although 0 doesn't have a sign, keep the sign. That's where our vertex comes from. And then when we look at what's happening in terms of the transformations, this time we have a negative inside of the parentheses, so it's inside the function. And what that means is that we're going to reflect our graph over the y-axis. Our other transformation is coming from the vertex. We're not going to move our vertex right or left because the x value in our order pair is 0. But we are going to move our graph up 4. Over 0, up 4. There's the up 4. The thing about reflecting over the y-axis is you can't see the reflection. What happens is we follow the same pattern. one space to the right, one up, but we're going to reflect it over the y-axis. So technically this point lands here because we reflected it over. We go from the vertex, which I just made blue, we're going to go 2 spaces to the right and 4 up. I think I got it. 1, 2, 3, 4, yep. But then we're going to take this point and we're going to reflect it. It is 1, 2 away from the y-axis, so 1, 2 on the other side. There's the reflection, but again, the pattern doesn't change because what we just graphed over here on this side is going to land on this side. But our picture ends up to be here. Same idea on letter C. We need to identify the vertex. Well, our vertex is going to be 0, 6. There is nothing added or subtracted to our x in a parentheses. So nothing is represented by 0. Don't forget that ordered pairs have parentheses around them. And then our transformation. Reading the graph left to right. This negative outside of the function means that we're going to reflect over the x-axis. Just a reminder here, this is the x-axis. Our other transformation is that we're moving up 6. And think about the ordered pair for the vertex, because that really tells us our shifting. Over 0, up 6. There's the up 6. Reflect. Take your hand and flip it. I know you can't see it on the video, but take your hand and flip it, because reflecting over the x-axis turns this graph upside down. So the normal pattern is 1 space to the right and 1 up, but we're going to flip it. So it's going to be 1 space to the right and 1 down. The normal pattern is 2 spaces to the right and 4 up. We're going to flip it. So it's going to be 2 spaces to the right and 4 down. 1, 2, 3, 4. And it's the same pattern on the other side. 1 space to the left, 1 down. 2 spaces to the left, 4 down. And here's our quadratic.